6.1, angles and standard position in Q1. What does Q1 mean? It means quadrant 1. When I make the Cartesian plane and label it properly, X and Y, we have 4 different quadrants, quad 4. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Not I, or IV. It's 1, 2, 3, and 4. For the remainder of this unit, we're doing something completely different. We're going to be talking about trigonometry. This is a really important visual for you to have in your head. And it's important that right at the beginning of quadrant 1, right here, it's going to be 0 degrees. Now today we're just going to talk about quadrant 1. So we're going to be talking about angles between 0 and, what would this angle be here? You're right! It would be 90 degrees. Okay? So from here to here would be 90 degrees. If I were to draw this point here, just for the record, this is called the terminal point. And I were to extend it like this, just for the record, again, this is called the terminal arm. If I were to take that terminal arm and go from 0 to all the way back to 0, how many degrees? I kind of let the cat out of the bag there. How many degrees would it be? It would be 360. So today we're just talking about quadrant 1, so we're talking about from here to here, it's 0 to 90. Here would be 180 because it's a straight line. From here to here would be 170, and all the way around would be 360. Now, I want to make the worksheets that you did meaningful, and I want to show you why we learned or relearned or remembered Pythagorean theorem and right angle trig. Oftentimes what we do is we drop from the terminal point down to the x-axis, or if it's in this quadrant right here, quadrant 4, we go up, but it's always to the x-axis to make a right angle triangle. If this point right here is x, comma, y, this would be x, this would be y. Yeah, so we want to see this right here as a radius that would swing around, and if we had an infinite number of terminal points that would go all the way around, we would form a circle. This radius can just be found by taking x squared plus y squared and finding the square root of that. So that's how we find our radius. Another thing that's actually pretty neat. Oh, I need to say something. So this right here is our theta, okay? Usually what you'll see is just a little burr like that, just without the arrow, but I like putting the arrow in because it really solidifies in our mind that theta is this 0 point to the terminal arm. The terminal arm can be here, and then this whole thing would be theta. Or the terminal arm can be here, and from 0 all the way around would be theta. Okay? So we're taking from the x-axis from 0 degrees, we're going up to that terminal arm, which extends from the origin to the terminal point, and that's what our theta is. Now, I want you to think a little bit about the homework that you did, those worksheets that you did, and I want you to think about what the relationship is here. I'm going to give you the relationship, but I want you to think about it, and we could talk about it when we see each other again on Tuesday. We have r cos theta, comma, r sine theta. Not only is this point x, comma, y, but when we have a terminal arm, when we are dealing with our quadrants, this value, the value for x is also r times cos theta, and the value for y is also r times sine theta. So see if you can make that a challenge for yourself this weekend. See what that correlation is.